One day in 1998, Susan Lachine, a microbiology professor at the University of Massachusetts Amherst, was looking for new and interesting microbes, as she has for 25 years. A forest like this one proved to be happy hunting grounds.
This is very wet soil, and in wet soil the oxygen does not diffuse, and so we find soils that are depleted in oxygen, that are anaerobic soils. And this is where we want to look, because microbes from these anaerobic soils will make interesting products, such as ethanol.
Indeed, the microbe Lachine discovered that day has become the basis of SunEthanol, a company she has since helped found. The bug, which is called Clostridium phytofermentans, or Q microbe for short, has proven to be a cellulose-munching ethanol manufacturer. It eats all kinds of plant matter and creates ethanol as a waste product. Most ethanol in the U.S. today is made from corn and uses only the sugary grain. The problem is it takes nearly as much energy to produce as it yields, and the corn industry can't possibly meet all of the country's energy demands. Cellulosic ethanol, based on prairie grasses, wood chips, corn stalks, and other plant matter, is a better bet, at least in theory. But penetrating the tough cellulose that holds plant stalks together is a challenge economically. Traditionally, when you make cellulosic ethanol, you've got to first pre-treat the cell walls of raw plant feedstock with chemicals to get at the cellulose molecules. That's an intensive, expensive process. Next, you add enzymes to convert the cellulose into sugars. This is the most expensive step. Then you've got to add yeast or bacteria to ferment the sugar into a mixture of ethanol and water, and then you distill it to produce fuel for your car. But the Q microbe eats the plant materials and creates ethanol directly as waste, so it should replace the enzyme and fermentation steps. It may also require milder and cheaper pre-treatment. Altogether, that should mean cost savings of at least 25%. The race to rid the U.S. of dependence on foreign oil means SunEthanol has plenty of competitors working on other cellulosic ethanol solutions. But SunEthanol executive John Fable says the Q microbe is unique.
Ours is fundamentally different in that it combines several of the processes that are now separate and into one single process, and thereby offering some cost reductions. And the other difference is the variety of biomass material it can process into ethanol.
Q microbe will eat pretty much anything, the corn stalk or other plant sources, even hay or paper.
This is how we grow the Q microbe in the lab. So we've made a culture medium, which you see in there. It's like a cocktail. A culture cocktail. And it has in it some of the nutrients that the Q microbes requires, and it also, that white material you see in there is actually paper. And as it grows, that white stuff that you see in there will actually disappear because it will be totally broken down and converted into ethanol.
The process has impressed the large ethanol producer Verasun, as well as several private equity firms, enough that they've invested several $1 million worth of venture capital into SunEthanol. It's using the money to try to scale up its technology to a commercial level and develop business partnerships. That's what it will take to determine whether the Q microbe can help drive American energy into a new era. For the AT&T Tech Channel, I'm Yasmin Garamani.